Hello and welcome everyone. Today's question is string subsequence. So subsequence pattern is a common problem of dynamic programming. So kindly watch this video till the end. I will tell you about memoization, then tabulation, then I will optimize this code, space optimization, then I will again optimize this code with only one array of m size. So if you want to know how to solve this question in of m space complexity, so just watch till the end. So first let us solve this question with using recursion. So first we have two strings. Our first pointer is pointing 0 at string 1 and j pointer is pointing at 0 of string 2. So if this string matches, then we have two options. Either we can pick this character or we can avoid this character. So include or exclude. So if we pick the ith character, then on the next step our string will look like this. Geeks for geeks. Now I is here and j is here. If I don't pick this ith character, if I don't pick this ith character, so my string will look like this. I move forward to next index and j still stays on the same index because we have g also here and k here and g s here. So we have one another occurrence also. So you got my point. If we find the character, then we have two options: either we stays on the same position or we move on to the next position. If character is not equal, then we have no other option but to move to next index. So j stays on the same index and I moves to next index. So using this, we have to check how many occurrences of string 2 present in string 1. So I will move here and this character matches. Then we have two other options. I will move on this path. Then I have then k and k is matching. Then I here and j here. Then s and s is matching. Then we have two options. Let me move on to this path. So now this and this character matches. Then I is here and s is here. So as you can see, our string 2 character has onto the invalid index or out of bound index. Then if j is equal to m, its length is n and its length is m. If j reaches m, then we know that string 2 we have found in string 1. So we will return we have found one occurrence. Or if I reaches to n, then we know that j still stays on valid index and I reached till the end, then we have no character to check and we will return 0. So this is our base case. Now let's jump to the code. First, let's create n and m and create a solve function. Then we will pass I, n, j and m. Then just write the base case. If j reaches till the m, then we have found one occurrence, and if not, then we will return 0 if we don't take the current index. So that's always the case. We will move till next index I plus 1 and j stays on the same index and take 0. If character is equal, if ith and jth character is equal, only then we are moving our jth pointer. So now take and note take. As you can see, I and j, we are changing I and j. So we can apply dp here. So dp, let's create dp of n and m size. Let's pass the dp, pass here, and now let's store the ith and jth position. If it's not null, then just return it. So now one more thing, we have to apply mode also. So just create the mode. Now here mode, and overall mode. So we have solved this question using tabulation. It's time to solve it using, sorry, we have solved this question in memoization. Now it's time for tabulation. So just comment out this code, and if you carefully observe, so before jumping into the tabulation code, we have to make this recursion function as simple as possible. So we are passing I, N, J and M. So I starts from 0 till N and J starts from 0 till M. So we can reverse the I and J values also. So if we start I value from N minus 1 till 0 and J value from M minus 1 till 0. So that's also possible. So just write that code. So N minus 1, M minus 1 starting from backwards. So if it's pointing to invalid index, like here, if it's pointing to invalid index, so 1 then 0, then dp, then same as it is in the previous function, we are moving I plus 1 index, and here I will move to I minus 1 index and j minus 1 index, and overall code is same. So now let's, from memoization to tabulation, we have to do one simple thing. We are considering zero based indexing. Now let's us consider one based indexing. So from n till 1 and from m till 1, but on strings we have zero based indexing. So while checking, just check I minus 1 and j minus 1. So now let's convert this code from zero based indexing to one based indexing. So we have n s1 m s2, and I have a dp array, not n m m, but n plus 1 and m plus 1. I will tell you why. So just if j is pointing to 0, because we are considering one base indexing, and now 0 index is invalid. So 0 index is invalid. Now same as the dp and same this code. Now for a and b, I am checking I and j, but I am passing n and m. So we just need to check I minus 1 and j minus 1. So now it's a valid index. So same as it is, the all overall code is same. So why n plus 1 or m plus 1? Because I am passing n and m. So it will check with index n and m. But n and m is invalid according to this dp. So we have to apply n plus 1 and m plus 1. So that's the reason. So it's time for conversion from memoization to tabulation. So from one base indexing to tabulation, it is easy now. So just look at the base case. If j is 0, so if I build an array of matrix, so j value will reach, so I value from 0 to n and j value from 0 to m. So what is base case saying? But base case says if j is 0, means this. If base case, if j is 0, then field 1, then field 1, and that's the base case. So now just move to tabulation code. So in the tabulation code we have n and n, m, a and b. So we have dp here, n plus 1 and m plus 1. So I don't care about the I just care about the j. I can be anything. I start from 0 till n, and j must be 0. So we will fill 1. Now let's start the for loop. So for loop will work from 1 till n. Like here, I have to fill. I have to fill from 1 till n. From 1 till n. So this area I have to fill. Here all the values are 0. From 1 till n, because we are considering one base indexing. So that's why one base indexing. So I value and j value. So this case, take and not take, just write this code here. So dpij means dpi minus 1 and j, dpi minus 1 and j, same as this code, not taken, not take case. So take case, if a of I minus 1 and b of j minus 1, if this is equal, then move to I minus 1, move to I minus 1 and j minus 1. So this is take condition, and we have to apply mode here. So dp mode and then mode. At the end, we have to return this n and m, last index n and m. So just return that condition. So that's the case. Now it's time for space optimization. So as you can see, we have I minus 1, I minus 1. I minus 1 means previous row, and I, dp of I means current row. So we can utilize two array of m plus 1 sizes, because n plus 1 is row, this is n, this is our rows, and this is our columns, and we only care about previous row and current row. So we can apply two array. So space optimization, so n and m. So just one thing, zeroth value is 1, zeroth value is 1. So now we can avoid this loop, and we can only care about one index, so zeroth index. So just fill the zeroth index with 1. Now apply the same for loop. So current also we have to make 1. So jth loop now. So dpi means current row, and dpi minus 1 means previous row. So now if character is equal, so dpi means current row, dpi means current row, and dpi minus 1 means previous row. So j and j is same. Now if this, suppose this is our, so let me make another array. Suppose we are somewhat at here. So we know previous and we know current. Now if I increases, so I means 5, I increases, I is at here. So now this current will become previous, and I have to initialize current new array. So previous becomes current. So just change the array and make current array new current array, and on every iteration I have to fill zeroth value with 1. So that's why I have written this case here. So you can write it afterwards also, so that's your choice. So at the end, you have to return dp of m, so previous of m, because we have just initialized our current array with new array, and I have to return the last index, so previous. So that's space optimization. The video is not end here. I have used two array. Now let's jump and use one array, 1D array. Sorry, I have used two arrays. Two arrays. It's time for space optimization, and I will use now one array. So how we can utilize one array and solve this question? So if you observe, I have two arrays, previous array and current array. Previous array and current array. And current array, suppose jth value. Here jth value and jth value. So previous jth value and current jth value. So this condition. So previous jth value and current jth value. I only care about this condition, and one more condition, current j, and previous j minus 1. So previous j minus 1, previous, this is previous j, so this is j, and this is j minus 1. So if I know its previous value, its previous value I minus 1, then I can utilize one array only. So if you think it like this, from, if I don't start from starting, and I start and if I start from right to left, then we can know its previous index. So now I minus 1, j I minus 1 will work it like previous. So instead of starting from 1 to m, I will start from m to 1. So just comment out this code and write another function. So overall code is same. I will use one array. So now just fill the zeroth index and start the loop. So for jth loop, instead of starting from 1 till m, start from m till 1. So overall code now is same. So I don't need previous array. So I I can avoid this condition. Current j is equal to current j. So I can avoid this. So I only care about this condition. Current j is equal to current j plus current j minus 1. So as I am starting from m till 1, so this j minus 1 index will work it like a previous array. So at the end return current m minus 1. So I hope you understood this code. Its time complexity is n cross m and space complexity is order of m. If you have any doubts, feel free to ask in the comment section. Thank you all for watching this video.